Welcome, everyone, to another episode of Vision Basic. What you are looking at on screen is a creation by one of my Vision Basic customers, Ray Cousins, and I'd like to ask you to stick around to the end, and I'll tell you what this program is about and how to download it so that you can play around with it yourself. I'll also update you on my progress with the improvements I'm making to Vision Basic, and I have another channel I'd like to share and a project that someone else is working on that you might find of interest. But first we're going to jump into what this video is all about. Each time you boot up your Commodore 64 and start using the RND function with its typical parameter of 1, you might have noticed that it generates the exact same series of random numbers. If you haven't noticed it, then you're not spending enough time with your Commodore. If I turn on my machine and type the following, I should expect to see the value 0.185564016 each and every time I boot up the machine. If you use a parameter of 0, you can bypass this effect, but the range of possible random values will be limited. If you doubt me, then check this out. And we're going to run it. And dangum, I was going to clear the screen first, but we'll just leave the garbage on there. But as you can see, not all the spaces are going to be filled up. Apparently just about every other space is being filled and every other one is not. Anyhow, let's stop it. And if you use a specific negative parameter over and over again, you will see the same value returned over and over. So print RND negative 0.03 will always return a value of 0.361568627 each and every time. It's a common practice to help improve the randomness of the RND function by typing the following: negative TI. And this will help to seed the RND function with a seemingly random value that will help to break the default pattern at startup. Here we are using the system clock to help seed the RND function. Since this value changes rapidly, it's a pretty effective technique. So for those of you who are just now learning C64 Basic, make sure to toss this tip into your toolbox. For games and simulations and such, you'll probably want your random numbers to be as random as possible. Otherwise, you might end up with a game, for example, that plays out the same each time it is run after a system boot. Commodore Basic allows you the luxury to choose between a predetermined set of random numbers or a more unique set of values. From what I understand, the sequence of values produced by RND1 eventually loop back around to the start. But I couldn't tell you how long it would take for the numbers to start repeating. It could take a really, really long time. I've been running a program that tries to find out how many values the RND function can dish out before repeating itself. And this program had been going on for numerous hours and has been compiled by Blitz for extra speed, and I gave up. It had produced more than 300 million random values without repetition, so yeah, I just gave up. The C64 wiki points out that there is a way for the RND function to get stuck on producing the same value over and over. So check this out. And we're going to run it. How mesmerizing. That could really mess up a game program, don't you think? I don't think this is likely to ever happen for you, so don't lose any sleep over it. Okay, stop. Okay, so let's get to the real point of this video. See, there are times when you might want to produce the same set of random values again and again on demand. You might use such a set to help generate the background for a game, like a starry sky or a topographical mountain range. Random numbers can help to produce a lot of data with little effort for things like these, but if you like the particular results of one set of random data, you might wish to be able to reproduce it on demand. As we now know, this can be done in regular BASIC with ease. But this isn't quite the case when working in assembly language, and Vision Basic's random number generator uses the output of Voice 3's oscillator of the SID chip to help generate its random numbers. And the numbers produced there aren't going to create any kind of reusable pattern. So what are our options? Well, I thought about trying to somehow jump into the machine language code of the RND function of regular C64 BASIC, but honestly, looking at the code there just hurt my brain. Plus, the routine there is actually kind of slow. Now, I personally just recently needed a massive set of reproducible random data in order to test a routine I'm working on that accesses GeoRAM memory. In order to test the integrity of my routine, I needed to prove that I could fill the entire GeoRAM with data without that data ending up in the wrong places. When data ends up in the wrong places, that's known as corruption, boys and girls. We don't want our data to become corrupted, well, do we? Of course not. So my test fills the GeoRAM completely with random data and then calls it all back to see if that data is exactly the same as when it went into the GeoRAM. If the data comes back corrupted, we know that the routine isn't working as it should. I needed to be able to produce up to 16 megabytes of random data. One approach would be to fill the GeoRAM with 16 megabytes of random data and then set aside a copy so that we can later perform our comparison. But we don't exactly have 16 megabytes hanging around in the rest of C64 memory. And even though you can use GeoRAM and an RU together in theory, I needed my test to be able to work on various incarnations of GeoRAM, whether actual GeoRAM hardware or emulated versions like those in the Turbo Chameleon 64 or the Ultimate 64. And by the way, the GeoRAM and RU emulations on both of these latter devices didn't seem to work together very well without issue. Now, I don't think I've updated my firmware on the TC64 in a long time, so maybe it's improved, but no, I couldn't get them to play together too well, so they're like a couple of quarreling kids. So I had to go with the other approach and use a reproducible stream of random data. But using the regular C64 BASIC's RND function to come up with 16 megabytes of random numbers was simply going to take forever. And I needed to be able to run this test multiple times. I needed to be able to generate a reproducible stream of random numbers at machine language speed. But how? Well, a light bulb went off, like in my head. What if I took values from the kernel ROM and somehow toss them into a crazy act of bit manipulation? See, the kernel isn't going to change, at least not on my machine. It's a definite constant that I can count on. Using bytes from the kernel, I could develop a random number generator that has a definite starting point for my sequence. And we need to switch over to Vision Basic. So here's what I started with. We're going to set up a pointer at locations 251 and 252, right here, that will point to our current spot within the kernel. I was going to type this all out, but I need to cut some time where I can, so bada bing, it's there. I'm just going to paste everything in. Here our pointer starts things off at location 57344. That's where the kernel starts. Variable RN is going to hold our random value upon exit from our routine, and it will range from 0 to 255. Now here we are taking the value already in variable RN and we are shifting the bits left 4 times. Bits that fall off the end will be tacked back on to the other side of the value. In other words, a value of 128 will be tacked back on as a value of 1. We will be losing 1 bit in the process, but that's okay. We'll just call it a happy little accident, like Bob Ross says. If we don't start off with the ASLA instruction, our random values run the risk of not being repeatable because we will be adding an unknown carry bit into the mix. Now, if you don't understand machine language, just follow along. You won't need to know machine language in order to use this routine, but maybe you can kind of glean what's going on here as I put more stuff on the screen. Next line. And here we set the y index to 0. We're not going to use it as an index, but we still need to zero it out. Next, we add our byte from the kernel to the value we shifted previously, and then we store the results back into variable Rn. So here we have Rn, shift it left 4 bits, y is 0, add from the kernel, and store back into Rn. Since we're trying to create a random number, we really don't need to worry about the carry flag in this edition. What will be, will be. Anyhow, this was my initial approach to generating random values. Shift some bits and add a byte from the kernel. Next, we have to update the kernel pointer. So, more lines, people. So here in lines 1030 and 1040, we are skipping forward into the kernel by 2,731 bytes, which is slightly more than a third of the way. The result is that it will advance by thirds and then advance by 1 when it wraps back around to the beginning of the kernel, thus allowing us to go through all 8,192 bytes of the kernel. Let's look at some values to help you understand this better. Our series of values will look like this. So first up is, I'm just going to type them in. At first it starts out, press enter, okay. At first, it'll start out as 57344, the beginning of the kernel. Then it'll add 2,731, and it will become 60,075. And then next we'll add 2,731 again, and it will become 62806. And then we'll add 2,731 again, and the routine will help to, well, I don't want to get ahead of myself. The next value, it'll wrap around and will be 57345. And then, of course, if you just want to keep taking this further and further, 6076 and 62807 and blah, blah, blah. So, line 1050 takes care of the wraparound for us. If our pointer goes beyond 65535, the carry flag will be set, and we then subtract 8,192 from the pointer, sending things back to at least 57344. We don't need to use an SEC instruction here, right here, because the carry flag will incidentally be set before the subtraction takes place. See, if this jump here happens, the carry, it will be because the carry had been cleared. But if it falls through to the next instruction, the carry will be set, and therefore you don't need to set it again, because like, why waste that one little byte, you know what I'm saying? Okay. But for the sake of clarity, if you're a beginner in machine language, I'd say put the SEC in there, you know. And that completes the subroutine. We'll put in a stopper to prevent accidental execution, like so. 990 end, I'll just type it, and we'll list it, and voila, there's our routine. And now we'll create a small program that utilizes our new random number generator. I've written the subroutine in assembly language so that we can use it in assembly language programs, but we're going to test it out with basic commands. We'll first set up a bitmap screen, and we'll go ahead and plop them lines right down in there. There we go. And I'm not going to explain the whole setup here, but we're going to set it up and then set the limits. And we'll simply plot little dots at random places all over the screen. Down a bit. Ba-doom. Now on line 100, we are fetching, the routine is called RAND, as you see up here, RAND, our new random number generator. We are taking the value and we're going to shift it over by 1 bit. So let's just say if it was 255, it would get multiplied by 2, which then becomes 510, I think, at maximum. But we're trying to shift it over so we can open up just one little tiny bit so we can make the number long enough to cover the width of the screen. So in line 110 here, after we've shifted this over, we fetch another random number and we just kind of pluck off one little bit, and then we add it to our previous value for x that had been shifted. So therefore, in effect, we are creating a random value from 0 to 511. Now notice that in lines 120 and 140, we go back to fetch a new number if it exceeds the limits for the bitmap screen. So here, if x is greater than 319, then it'll go back to 100 and start the process over. And likewise, if the y value ends up being greater than 199, it will go back to 130, and it'll fetch a new value, and it'll do it again and again and again. It'll kind of pause things a little bit, but our numbers will, they don't stay that long out of range, so at machine language speeds, it's alright. And now let's run it. It looks fairly random, but you'll notice that it stops at some point. This means that our values are starting over from the beginning, and we don't exactly want this. And there you go, see? It stopped. Actually, the program hasn't stopped. The values are repeating themselves. So we'll press the key to get out of here. Now at this point, I tried changing the shift pattern in line 1010, as you see here. The best I could come up with was to remove all of the ROL instructions, but even that didn't result in the screen completely filling up with dots 100%, and the results didn't look 100% random either. So the thought occurred to me, why don't we just grab another byte from the kernel and throw it into the mix? So that's just what I did. Now let's go up here to line 10, and we're going to insert, create a new pointer. And here we just created another pointer at locations 253 and 254, because half of this will go into 251, the other half will go into 252, and then this will go into the next byte 253, and the other half of this will go into 254. And we are poking the value of 60,000 into both 253 and 254. I just chose 60,000 because it's simple looking. I didn't want to type some weird number. I knew it was in range within the kernel, and I chose it, and just whatever. Looks nice, pretty, 60,000, beautiful number, let's go with it. And it really doesn't matter a whole lot. I figured you just don't want it like too close to any of the other values initially. So. And next we'll modify line 1020. So we will go down here to 1020. And we're going to type this. SBC 253, comma Y, colon, and press enter. Or return, sorry. I figured, hey, let's go ahead and do a subtraction instead of another addition. So what we're doing here is we're adding a value from this pointer, 251, 252, from the first pointer we have, and then we're going to subtract a value stemming from the other pointer we created, and then we're going to store the results in RN. And again, we don't need to worry about the carry flag because it's likely going to help contribute to the randomness. And instead of advancing by leaps and bounds, let's just increase our new pointer by 1 for simplicity. So, new lines to be added. We'll have them inserted here. And we're erasing 1060 with this new line here. Now the reason I set the wraparound value to 57345 right here instead of 57344 is to help keep the two pointers from staying in sync. You don't want the two pointers, 251, 252, and 253 and 254 to stay in sync with each other. Otherwise, once 8,192 values have been gone through, they'll just line right back up, and they'll be in sync with each other the whole time. So there's a chance that the values may not be, stay random. The pointer at 251 and 252 will run through 8,192 values, and the pointer at 253 and 254 will run through 8,191 values. And let's list it to see the whole program, nice and pretty, and then run it. and warp it, just for fun. The results here look pretty good to me. Perhaps on some level they might not be perfect, but I can't really tell. If we leave this running long enough, the entire screen will fill up completely, and that was really one of my goals here, to create a long enough stretch of random values. It's mesmerizing. Okay, press tab, or press a key. I mean, if I just leave this running, it's going to take a while. I mean, a lot of dots are going to plot on top of each other and stuff. I mean, you should know that. So yeah, we're just going to stop right here and get warp mode off. I mean, that was in warp mode. Now the slowest part of that process was the plotting of bitmap dots. So the rest of the program probably runs pretty quickly. Now, the one issue with this technique is that there are different versions of the kernel out there, so results will likely vary among machines. And I mean, if you write a game using this routine and you're like, hey, everything looks cool, the background, the stars or whatever you create randomly, they look the way you want, and then you hand this game over to your friend and he's got a different kernel, well, the star layout might look a little different. So I tried using the character ROM next. It seemed to work pretty good, but the bitmap screen never filled up 100%. So the pattern managed to start over again prematurely. Honestly, I wouldn't be surprised if all variations of this technique start back over from the start eventually. The issue with using character ROM is that it's a smaller set of data to source from, and the character ROM is full of repeating values and such. But my hope was that it would be consistent between machines, unless you have a custom character ROM installed, of course. Let's go ahead and load up a version of the program that employs the character ROM to generate random numbers. I don't need 8. Okay. I made some improvements here to the original program. If you look at lines 100 and 110, you'll see that we're dividing the random numbers by values that help to keep them within the screen limits, though an occasional value will end up off screen by a single pixel every now and then, and Vision Basic will simply refuse to plot it, so it's no big deal really. The end result, though, is that the program executes almost twice as fast now, because we're not trying to fetch a new number every time one turns up out of bounds. And line 1010 has the routine call itself, so that it can copy a random value into the high byte of variable Rn. After calling itself, flow continues into the lines that follow so that the low byte can receive its own random value. So here you can see that this routine is kind of calling itself. JSR 1020 calls this and then copies the low byte of Rn and stores it into the high byte. And then the flow continues into this part, and then it hits return and exits the routine. Also, in line 1030, I've added another layer to the madness, and this seems to have extended the number of random values produced before they start to repeat, so this program will actually fill up every pixel of the bitmap screen. We're using location 255 to store a counter of sorts. It runs from 1 to 111. And this value gets added to the random seed. And the reason I chose to use a counter here instead of another pointer is that I've kind of run out of space to put pointers. In 0 page, we had like one more byte left, so I'm like, okay, well, since we can't turn it into a pointer, let's just make it a counter, a little byte here. So yeah, 251, 252, 253, 254, and 255 are all used. So going back to this line here, we take the contents of 255, we compare to see if it's 112. If it's less than, we just branch past all this madness here. And if it's greater than, or equal to 112, then it takes, it'll load a value of A and store it into that location. So essentially, it's a counter, and actually it gets incremented up here. And lines 1020 and 1120 help to open up the character ROM so that we can take a peek at it. Let's go ahead and run it so that you can see that the results do appear random. And remember, we're using character ROM this time, people. Alright, it's like deja vu. And we'll exit. Initially, I thought I was going to be done with this video by just showing you all the kernel method of generating random values. Then I checked into making a character ROM version because of the issue I mentioned about there being multiple versions of the kernel. But this got me thinking, why not see if we could cough up a set of random values and use that as our pool to pick from? It might not work, but maybe we only need 1K of values to pick from instead of the 4K of character ROM. So I went into regular basic and had it spit out 1K of random characters into a file that we can load up. And then I modified my random number program yet again. So let me go ahead and load up that version real quick. And here you can see that it loads up a file called random pool in line 10. I'm pretty sure I only had to modify things in a few places so that it will only cycle through 1K of values instead of 4K, so let's just go ahead and run it. And let's warp it. And you know, it actually worked. Granted, you would need to sacrifice 1K of memory to house the random pool, but ROM differences wouldn't be an issue anymore. And yes, this version will also fill the screen completely with fill the screen completely with dots. There you go. And yeah, this is becoming a bad case of deja vu. You guys are like, I'm seeing the screen fill again. Okay. And then I was going to wrap things up for the video. But then I figured, why not see if we could do the same with only 256 values? If it worked, then we'd only have to sacrifice 256 bytes to the random pool. It was a long shot, but let's see what happened. Load new RND 4. How high will this number go? Let's find out. I tried running things with the smaller pool, but I'm pretty sure the bitmap didn't fill completely, so I added another 2 layers of values. I didn't need pointers anymore because we're only dealing with 256 values, so I turned locations 251 to 254 into indices or indexes or however you want to pronounce it. I'll just say indexes. You can see this being done in lines 1050 to 1080 here. These are now indices or indexes. They get loaded into the Y register. And then I jump around in the indexes with values like 85, 37, 23, and 117 as seen in lines 1090 to 1120. Right here. 85, 37, 23, and 117. Also, to help keep all the indices from lining up with each other, as we mentioned that earlier, the index in line 1100 only cycles through 255 values. The index in line 1110 only cycles through 253 values. And the index in line 1120 only cycles through 249 values. So, here we go. These actually show the range here. So, we're cycling through 255 values for this index, and 253 values. We're only cycling through 250 of them, 253 for this index, and 249 values for this index. All of these are negative prime numbers, which also helps to ensure that they don't all line up for a very long time. At least that's my theory anyhow. And the results, let's run it and find out. Space, the final frontier. Oh, space is going berserk. And again, more deja vu. And let's stop it so that I can talk and focus. So I stood there in awe at the realization that we only needed a pool of 256 values and 5 layers of adding or subtracting. Now I can wrap up this video, right? It was bedtime at this point, so I ran off to bed. But then a seed entered my mind as I lay there in bed, could we just eliminate the pool altogether, saving the memory for the user, and just combine a bunch of looping values? I didn't think it would work, but what the heck. So the next day I whipped up yet another version of the program. And we will load that too. New, load, new RND 5. We're on our 5th version now. Essentially, this routine is pretty simple. We have some seed values in line 0. These are all seeds here, including RN. That's actually a seed as well. They can be set to whatever we want, and this should give us a different starting point for each set of values combined. In lines 1020 to 1030, we are simply adding and subtracting 5 total values to and from the random seed byte. And we have a little bit of bit shifting going on. In line 1040, we are just adding a value of 85 to the value in location 251. In line 1050, we're just adding a value of 37 to the value in location 252 and limiting the range to 255 values. This will exclude 0 as a possibility. In line 1060, we are adding 53 to location 253 and limiting the range to 253 values, 253 values. In line, that's confusing, isn't it? In line 1070, we are adding 103 to location 254 and limiting the range to 249 values. And in line 1080, we are adding 73 to location 255 and limiting the range to 245 values. And it's important that the limiting value, like the value of 245 here, in line 1080 is not divisible by the value being added, which in this case is 73. Otherwise, the range of possible values would be fewer. So let's just pretend for a second that this value was divisible by this value 4 times. Essentially what would happen is it would cycle through the same exact 4 values over and over again. You would not get the full spectrum of 245 values. I pretty much went all out prime here, which I think helps a lot. But since all we have here are a bunch of looping values, could the results even be considered random? Will they even look random? Well, the only way to find out is to run the program, of course. So therefore, we will type run, and we will run it. And there you go. Well, I mean, it looks pretty random to me, don't you think? And even more amazing, the entire screen does end up being filled up with pixels. So I'm not sure why this routine couldn't be used to generate random values for a program. And the whole point of this video is exploring ways to create a set of random numbers that can be reproduced again and again. I'm going to go ahead and stop it, lest I stumble on my words. So, if you like any of these approaches, feel free to use them in your own programs. Let me know in the comments if you come up with your own ideas for random repetition. And now, we're going to load up something here called WATOR, and we're going to run it. Now, we're going to take a quick look at the WATOR program created by Ray Cousins. I'm not going to go into a lot of details here. Ray has provided an excellent description of the program and has given a pretty substantial outline for what each line or sets of lines does. All of the programs shown in this video will be available in a file download that you will be able to find on the media page of my website, visionbasic.net. Now, it may not be available immediately, but I will try to get it up there as soon as possible. Could be a day or two. I'll provide a TXT file in the download that includes all of Ray's information about the program. I'll provide a TXT file in the download that includes all of Ray's information about the program. Now, quoting Ray, the idea for this project came from the book The Armchair Universe by A.K. Dewdney, D-E-W-D-N-E-Y, in which he describes a water world made up from just sharks and fish. I like that name, Dewdney. It's almost like being doodly. So here we have a menu. If you select 2, and I'm going to press 2, it will take you to a page where you can change the parameters from the program defaults. I'll run down this list, but I'll keep the defaults. So we'll start out with 100 fish, as it says, and we'll start out with 10 sharks. Why not? And we have the fish breeding age, I think. We'll just go with 4. And then the shark breeding age, 10, because they're bigger. They don't get to breed as early. And then how long it takes for a shark to starve. So we'll just go with 8. And I guess the fish don't starve. They get eaten, so I guess it doesn't really matter. I mean, theoretically, yes, they could starve, but hey, we're just gonna let the sharks starve because they're the baddies here. So, and then you can run the simulation by pressing 1. Now, each of the dots on the screen represent the fish, and each letter D represents a shark. There can be up to 960 ocean critters on the screen, so there is a lot to keep track of here. Each fish or shark has multiple variables associated with it, and they each move about the screen. I gave Ray some tips on faster array access, but I'm sure we can still optimize some things. Only pure machine language can make this much, much faster. Thankfully, we have warp mode in Vice, so let's see what that does for us. I like me some warp mode. And we have a lot of fish, and the sharks are starting to gobble them up. And then the sharks will start to die out, and then the fish will start to come back. I think this is a fascinating program to watch, really. I think Ray did an excellent job here and in his documentation. So for those who don't have Vision Basic, you can still run the VEX file provided on the disk image. So you can use this like as a little screensaver running in the background or something. I don't know. It's kind of neat. Gobble, 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 gobble. And then the sharks are just like, man, I'm hungry, and then they die. And I think on a rare occasion the program will stop, because if all the sharks die, it's like, well, can't do nothing there. It'll just fill up with fish, and that'll be kind of boring. So yeah, on occasion, I think one time I ran it and all the sharks did die out. So, but this is kind of cool. So. And then you press, what do you press to get out? Q, quit. Okay, and we'll get the warp mode off and press the key for options, and we will quit the program. Now I'm going to share another YouTube channel with you. The channel belongs to Brian Kumanchik. Kumanchik? Yeah, I think that's how. He currently has a series called My Journey in Game Programming, and he's quite a tinkerer. I think you'll find his work fascinating, so please check out his channel and subscribe to it if you like what you see. I'll post a link to his channel in the description. And there is a project I have been following lately. It's a crowdfunded endeavor by Jeff Skop titled I Adore My 64, the film. I've donated to the project, and I hope I can stir up some support among my viewers. I don't know Jeff personally, but if you check out his campaign, I'm sure you will see the professionalism he can bring to such a project. At least check out the links I provided in the description. The deadline for donors is quickly approaching, so please check it out. Alright everybody, I forgot to record this little section here, so this might sound a little different. I said that I was going to update everybody on the progress with Vision Basic so far. I'm working on a version 1.1 at the moment, and so far I've made a lot of fundamental changes to the software, including what I'm about to tell you, and I'm sure you already kind of have a hint of this, but I'm trying to get Vision Basic to be able to work with GeoRAM. So far my tests with the routines that I've written for GeoRAM have come back. They've worked perfectly fine. So that is my update, and pretty much the only one I have, because I've been working on these routines for I mean, just like weeks and weeks and weeks. So, is it a routine or routines? I don't know. But anyways, so yeah, there's my update for everybody. Yeah, for everybody, and give it a couple months, and I'm hoping to have it finished, all the work for version 1.1. Alright, that wraps things up for this video. And again, I'll be tinkering in the meantime, and probably be doing yard work, and eating food, and bathing, and working my retail job. So, anyhow, as usual, I thank all of you for watching my video. Please like and share my video, and definitely subscribe for more similar content. And make sure to visit visionbasic.net.